Algebra and surds again. Algebraic fractions this time we'll check out. A few key examples. This one is asking us to simplify this one here, x minus 3 on top and x squared plus x minus 12 on the bottom there. Please resist the temptation to just say, okay, minus 3 goes into that once and minus 2 goes into minus 12 or whatever 4 times. You can't do that. You can't just cancel out individual items on the top and the bottom here. The step we need to take is to factorize the bottom and see if one of the brackets that occurs on the bottom is an x minus 3 and do a bit of major cancelling out here. So I'll show you how that works. Let's do PSF on just the bottom bit. So the product of two numbers that we're looking for to put in some brackets like this, we'll have x in the beginning and x in that bracket there, and we're looking for two numbers to go in the brackets here on the bottom. So the product of those two numbers is found by checking that the product of those two numbers is minus 12, and invisibly there's a 1 there. The sum of the two numbers we're looking for to fill in the brackets is a 1. Now the factors of minus 12 that have got something to do with 1, we can have 1 and 12, 2 and 6. I'm here to tell you that 3 and 4 looks like they probably work quite nicely. And we need to create a minus 12, so one of these needs to have a plus or a minus next to it. When we add these two together, it needs to be a plus 1. So the bigger of those two numbers needs to be positive, so we'll need a minus 3 and a plus 4 to go into there. So we'll end up with x minus 3 on top, which is just from the question. We didn't do anything fancy there. We can create an x minus 3 as one of our brackets using that minus 3, and an x plus 4 for the second bracket. Now you can spot, I think, that we could probably think of this as being a bracket, and we could cancel these out. Now do not cancel them out so that the top totally disappears. The proper way of cancelling this out is saying a bracket of x minus 3 goes into the top once, so we'll end up with a 1 on the top, be careful with that, and it goes into the bottom once as well. So the top doesn't just cancel out totally and disappear. We'll do the little ones there to make sure this is processed correctly. So we'll have a 1 on the top and just an x plus 4 on the bottom. In the end we might put it in brackets. So yeah, factorize the bottom using PSF, and in most cases there'll be a whole bracket that can be divided into the top and bottom, and if we do that carefully, that'll be fine. If we just cancel them out recklessly, and we might think that the final answer is x plus 4, but that x plus 4 is on the bottom and should stay on the bottom, even if the top has to have a 1 on it. Careful with those. Alright, now just because these got letters in them doesn't mean it doesn't follow the normal everyday subtracting of fractions. Before we subtract fractions, we've got to get the same bottoms, same denominators. So we'll need 20 on the bottom here. That's the lowest common multiple of 5 and 4. We get that by multiplying those two together in this case. Alright, what have we done to the 5? To get 20, we've multiplied by 4 there, so we better do the same to the top. If we multiplied that m by 4, we'd have 4m. What have we multiplied the bottom by? 4. To get 20, we've multiplied that by 5, so we better multiply that by 5. 5 lots of 3m is 15m, and there's a minus in between. Once we've got the fractions to be having the same bottoms, we're allowed to subtract across the top and keep the bottoms the same. 4 minus 15 is minus 11m, and the bottom would be your 20. So it really acts the same as having fractions that are full of numbers. We're just following the same process, but involving letters as well. Not much different to normal ones. Okay, this one here, a little bit more complicated, but still it's subtracting fractions here. So what we will have is, we'll try and turn these both into something over 12. And minus another thing that's over 12. If we've multiplied that bottom by 3 to get it into 12, we'd better multiply the top by 3. Now when we do, we'd better do it carefully with brackets there. So I actually got 3 outside of A plus 3. If we multiplied the bottom here by 4, we'd better multiply the top by 4, and we'd better do it carefully. Okay, and we're allowed to then subtract across the top and keep the bottoms the same. So we'd have 3a plus 3 minus 4a minus 2 all over 12. Now if we did some expanding there, we might be able to actually simplify the top a little bit here. If we expanded that and expanded that, we might be able to collect some like terms, but we'd have to be mighty careful about it here, because particularly in that second half, because anytime there's a minus in front of some brackets, you've got to be pretty careful of it. We actually have 3a plus 9 minus 4a, and then we'd have minus 4 times minus 2, which is plus 8, all over 12. And we can collect these like terms. 3a minus 4a is minus 1a. And then 9 plus 8 is 17. And that's got to be over 12. Okay. Still pretty ugly, but still. We added the, we made the bottoms the same, then we subtracted across the top and kept the bottom the same, and we expanded and collected some like terms. We collected the a's together and we collected the normal numbers together as well. So that's as far as we can go there to simplify that one. Let's check out the next one. Alrighty, boy. Okay, here we go. So now to get the same bottom here, boy, we're going to have to multiply this and this together. So this is going to be quite interesting. Just like when we had 4 and 5 on the bottom there, or other numbers there, we had 3 and 4 is 12. We're going to multiply those two numbers to get a common bottom, common denominator. So we'd need a b plus 2 outside of a b minus 1 for that first term, and a big minus, and you'd need a bracket, another line there, fraction line, b plus 2, b minus 1. Alright, now we ask ourselves, to create, we had a b plus 2 on this first term, and to create that bottom there, we would have had to multiply it by b minus 1 on the bottom. So if we've multiplied this by b minus 1 on the bottom, we need to multiply this top by b minus 1 as well. So we have 4 outside of b minus 1 on that one. Now, we had a b minus 1 on the bottom of this second fraction, and we've multiplied it by b plus 2. So we'd better do the same to the top. Complicated, I know, but we're just keeping our wits about us here. A 3 outside of b plus 2 would be done there. Now we can write that all out as having the same bottom. That's the whole point of arranging it so it's got the same denominator there. You got 4 outside of b minus 1 minus 3 outside of b plus 2 all over that combined one there, b plus 2, b minus 1. Alright, so I'll just save room here. I'll come over here, and we're going to be expanding these to see if we can collect some like terms on the top. So on the top we've got 4b minus 4 minus, we'll be careful with this here because the minus in front of the brackets is a bit prone to error, minus 3b, minus 3 times plus 2 is minus 6, all over b plus 2, b minus 1, lots of fun. We'll collect like terms here, 4b minus 3b is b, and minus 4 minus another 6 is minus 10, all over b plus 2, b minus 1. And that's the best we can do. If change itself's got the same bottom, but it's still pretty ugly. But that's, yeah. So we're using a lot of fraction rules here. We're creating the same bottoms, and we're doing whatever we did to the bottom, we've got to do the top and all that sort of stuff. But yeah, it's a challenge, that's for sure. You got to keep your wits about you and concentrate, otherwise you might go wrong there. Okay, like a challenge, don't we here? I'm here to tell you we'll factorize a lot of these things. We could use PSF on this this top one. I might cut to the chase here a little bit, because each of these are individual factorizings that I'm sure you can cope with. But I just want to show you what ends up happening when we have factorized them all, because we've already looked at factorizing in the last massive video. But I'll just cut to the chase here and tell you that this top bit here ends up being, when you factorize it, m plus 5 all squared. This bottom bit here can be written as m squared minus 3 squared. So he will have an m plus 3, be a difference between two squared situation, and an m minus 3. That's how he turns out. We have an m minus 3 on top already there, and if we factorize out the 3 there, we will have a 3 outside of m plus 5. And that allows us to do some big cancelling with some brackets there. So let's have a look. We're allowed to, when we're multiplying fractions, there's a rule that says we're allowed to multiply and divide the tops of one fraction and the bottoms of a different one. So see this m minus 3, that can divide into the top of that fraction and go once, and into the bottom of that fraction and go once. We're allowed to do that with multiplying here. We also notice that we have an m plus 5 squared, which is like an m plus 5 and another m plus 5. That can cancel out with the m plus 5, or divide in with the m plus 5 down the bottom of the other fraction. That can go in there once and into there once, which leaves us with just an m plus 5. So effectively it cancels out the fact that that's squaring. Can you see that? We divided the bottom of that fraction by m plus 5 and the top of over here by m plus 5, and it went in once and just left us with one of those m plus 5s. And so in the end, what has survived all that cancelling out? We have an m plus 5 on the top multiplied by 1, so we'll just write m plus 5 on the top there. And on the bottom we have a 3 that's surviving, and an m plus 3 that's surviving. And that's our best, simplest version of that. So there's a lot of factorizing that's gone into that. That's actually a perfect square, this one, but if you did PSF on it, you'd have 5 and 5 as your two numbers. This one involved a rule of difference of two squareds, because we could write that bit as m squared minus 3 squared, and you're able to write it out as m plus 3, m minus 3. And we just factorized out here. We took 3 as the common term there to create 3 outside of m plus 5. Once we factorize all of them as much as we can, we look to then cancel out whole brackets, but don't forget to do it properly. You say that the bracket divides into the top once and into the bottom once. Those ones are important there. We saw that in a previous example. Alrighty, so there's a bit of opportunity to apply the rule here of dividing by a fraction. You multiply by the reciprocal, which is the second one turned upside down. So just to apply that rule straight away, first one can be listed. When we divide by a fraction, we can multiply by the second one turned upside down. Okay, now some of you might be able to spot there that you have something that can factorize out the top. So common here between the 5x and the 30 is a 5. That's a 10. And I'm going to write the x plus 6 in brackets here to allow you to spot the fact that they're that can be divided into the top and the bottom. So we can say x plus 6 goes into itself once there and into there once. So we're allowed to do that across the tops of one fraction and the bottom of another. 5 can divide into that once and into there twice. So in the end, the things that survive once we've factorized a little bit and done a bit of cancelling out, on the top we've got a 5 times a 1 times a 1. So we have a 5 on the top, and on the bottom we have a 2 times an x times a 1. Just 2x there. So that once that factorizing and cancelling happened there, it's very simplified now, isn't it? So there we have that one. So a lot of factorizing carefully, and then a lot of cancelling down of things that can divide into the top and bottom, but have to be done carefully with putting the little ones in there, and often the answer is just what survives after all those things occur. Alright, that's that one. So we'll catch you next time. peterblakemaths.com. Thanks for listening.